So I have to switch my project to the correct one here. So group B. And then I'm going to just double check that we finished off the housing enough that we can do the assembly. I think we got that far last time. Let's see, yes, we both did the revolution, and we even got all 4 holes in the flange. So we can actually start doing the assembly right away. If you feel like it later on, you can finish off the housing, creating the missing flanges and the features of it. But for now, the important part for us is to be able to assemble all of the parts together, so that that's what we're going to focus on. So we're going to create a new file, and we make sure that we're in the metric folder, and then we'll go over to the standard in millimeter.iam file. So an assembly file, standard in millimeter. And then we click create on that one. So the first thing we'll put out is the housing itself, and we're going to lock it to the center of our coordinate system. So I'm selecting the housing up here, and then open. And in case some of you might have place from content center as the default option there, then you just use your drop-down menu and select the place one there before you select the housing. Then you select the housing part and click on open. So before we continue on with anything, I'm just going to let everyone catch up. So if we have everyone in place inside the assembly here, we've gotten the part in. We haven't actually placed the part yet. It's following our mouse pointer around. So what we're going to do is to click on the right mouse button to get up an extra menu. So we click on the right one. And then we're going to choose the Place Grounded at Origin option. So the one I'm highlighting here, Place Grounded at Origin. Once we click this one, it's going to place the housing, and it's also going to lock it to where the X, Y, and Z coordinates are all 0. So it's going to lock the center of our housing to the center of the coordinate system. So there, that's locked it in place. I don't need to place any more of the housings, so I can either press Escape or OK here in order to exit that one. And I'm just going to flip it a little bit around to see it from a better angle, like this. And just as a reminder from the last assembly we made, since we grounded this one at the center of our coordinate system, we can actually see that there's a thumbtack on the icon over in the browser window there. So on the housing icon, there is a thumbtack on it, and that means that it's stuck there. It can't move, so we can't drag it around or anything like that. It's always nice to have at least one part that has been grounded like this, because that's going to lock our assembly in one place once we start fitting them together. And they're going to be stuck there, so we can't accidentally start dragging and pulling them all over the place. So the next thing we're going to do is to place the other 3 parts that we have modeled. So we go back into the Place window. And I'll do the shaft first. So I'll zoom out a little bit to get some more room here. So I'll place the shaft. And remember not to do Place Grounded at Origin with this one. Just do OK once you've placed it. And then we can place the next one, the valve flange. And again, just OK or the escape button. And we can also place the wheel. If your parts, when you're putting them out here, are oriented in a different way than what mine are, that just means that you chose a different plane than I did when you created your initial sketch. So when you started modeling your parts, you started modeling in a different direction from what I did. But that's not a problem, because everything is going to be rotated into place once we start constraining them to each other. So it's going to look all right in the end. So we'll just let everyone get a chance to place all of these parts. So the next step is that we're still missing something because we haven't modeled everything that we're going to use in our assembly, because we are going to use some bolts and nuts in order to fit the top of the valve onto the housing. So we're going to need to put those in. We also need a nut to fix the wheel to the tip of the shaft. So that means that we're going to have to get them from somewhere. And in order to get them, we go into the drop-down menu up here, below Place, and we use the one that actually says Place from Content Center. And this is the library part of Inventor. So you're probably ending up somewhere out here, or even further away from that. With this library part, there's a whole lot of different kinds of mechanical parts that are regulated by standards, so ISO standards or API standards or whatever. And since they're regulated by standards, they have set dimensions. So we can just pick them from the library and get them placed in here without having to model them ourselves. So it saves us quite a lot of time when we're doing assemblies, just being able to pick all of this. So you can see over on the side here, it says Fasteners, and we can see the other directories that we have here with bolts, nuts, pins, rivets, washers. It's also possible to go to cable and harness to get different connectors for cables if you are putting cables into your models. You can create molds for molding stuff, O-rings, grease fittings, drill bushings. There's quite a lot of different stuff that can be picked directly from this content center. But we're going to use fasteners in this one. And the first thing that we're going to place is bolts. So we're going into bolts. And what we want is regular hexagonal headed bolts. So that's the second one here. It means that the head of the bolt has 6 sides, so it's hexagonal. You also have other types. You have a hexagonal head, which is flanged, that you can have. A socket head has an internal hexagonal opening, where you can use a typical Unbraco wrench to use it. You can have square heads, so that they're square instead of hexagonal. But in this case, usually what's being used is hexagonal heads when there is no other considerations to take into account. So we'll open up this one. And we can see now we're getting up quite a lot of different standards that are being listed. And we can even see that we have a couple of more folders up here. So we have the possibility of choosing, for an example, a self-tapping screw, if we want that one. That is one that has, you can actually see it a bit in the folder here. It has a small groove cut into the tip there, so that if you try to screw it into to a soft material, it's going to create its own threads as you're screwing it in. So for an example, if you're going to use it in some sort of plastic, you only need to drill a hole. You don't need to thread the hole first. You can just put the self-tapping screw straight in. You also have special ones for sheet metal, so very thin sheets of metal. You can use sheet metal screws on. And you can have shoulders, and then you have the regular ones, and a couple of other. So now we're going to figure out which one we need. So we need to look in the compendium. And we're going to use the one that's called DIN ISO 4014. It says so on page 284 of your compendium. So DIN, D-I-N, that is, I can't remember what the I is for, but the D is for Deutsche, so German, and the N is for norm, so it's a standard. And the EN is for a European norm, so it's a European standard, and ISO is, of course, the International Standardization Organization. So we need to find that one. We can see we have one that is, they're close to it. We have 4015, 16, 18, but these are BS, so they're a British standard. They're not the German one. So we need to go a little bit further down, and here we can see the DIN is starting to pop up. And we were supposed to have DIN EN ISO 4014. So once we have marked that one, and just to make one thing clear, even though we have hundreds of standards to choose from here, quite a lot of them are going to give you more or less exactly the same bolts, because like you saw up there, we had a British standard with the EN and ISO behind it, and here we have the German standard. So there might be a few small differences to them, but it might just be as little as a small radius that is 0.1 on one of them and 0.2 on the other. So they can be really small, those differences. Once we've found that one and marked it, we click OK. And then we can click somewhere where we're not clicking on anything else, so where we have this red question mark. So we'll just click there, and we're going to get up a new window. And these ones were supposed to be M12. So we'll go down to M12 in the thread description. And they're supposed to have a length of 50 millimeters. So we're going to use the minimum length on these ones. But you can also have them all the way up to 120 millimeters in length for this size. As you will see, if I go down on, for an example, M30, just to show a larger thread, then we get different lengths. So it depends on how thick the bolt is. But we are supposed to have M12 and 50 millimeters in length. Once we click OK, like this, we get a preview of the bolt following our mouse pointer around. For now, we're just going to place one bolt, because once we have constrained it in the correct position on our valve, we can use a circular pattern in order to create the other three bolts in the other holes. So we'll place one bolt right now, then we'll right click and click OK in order to exit that bolt function. Then we need an M12 nut. So now we need to go back into the content center in order to find that nut. And then we need to go over in the browser window and either go back to the fasteners and find our way from here and into nuts, or we can just click on nuts over on the side here. And there we can see there's quite a lot of different kinds of nuts to choose from here also. You have capped nuts, which are going to, they have a small protective cap on the end so that they're basically protecting the tip of the bolt that is going through the nut. You have the regular hexagonal ones, which is the one we're going to use. And you have quite a lot of other types. You have slotted in order to be able to lock them in place. And you have wing nuts, quite a lot of different. So we're going for the regular hexagonal ones. And again, we have quite a lot of different standards to choose from. And for this one, we're going to have the same again, the DIN and then EN standard. And we're going to have ISO 4032, so 4032. So we need to scroll a little bit down to find that one, I think. So let's see. There it is. DIN, EN, ISO, and 4032. Once we found that one, we're going to do the same as we did with the bolt. We're going to click OK. And then we're going to place it somewhere so that we can set the dimensions of it. And with a nut, you can't set the length or anything, so you only set the thread size. And we're going to have an M12 nut in order to match up with our bolt. The last nut we're going to save for a little bit later, because we're going to do some automatic stuff with that one, so that inventor is going to choose the thread designation for us. We're just going to show inventor where it's supposed to put it, and then it's going to automatically size it from that. So first off, we're going to start constraining together the valve housing, the top, and the bolt and nut that we've already placed. So we're leaving the shaft and the wheel for now. So we'll go into the constrain option. And last time when we did assemblies, we only worked with the mate type, where we put one flat surface against another flat surface, and they would either be facing each other or they would be facing the same direction. This time, we are mostly going to use the insert option, and those are the two that are most common in use when you are placing something. So the insert option is over here, and it's specially designed for use with cylindrical objects. So we'll start off by getting the top of the valve connected to the top of the housing. So we'll go down to the top of the housing here, and we'll choose the outer edge of the flange. That will be our first connecting point. And then we'll move our mouse pointer over to the valve top, and we'll choose the lower edge of the flange. Once we click those, they are going to snap together. But since our housing is grounded at the center, it's only the top that is going to be moving. Right, so if you're going to continue placing constraints, it is enough to just press apply, because then you can start placing your next constraint directly. In my case, I'm going to press OK because I'm going to show some more stuff, so then I have to open up the constraints menu again afterwards. Now I'm just pressing OK there. So what we've done now is we've connected the top to the housing, so that it can't move vertically in any direction. We've also connected the axis of the top to the axis going through the housing also, so it can't move anywhere sideways. The only movement that is left open to the top here is that it can be rotated. So it can be rotated around the axis. So now we're going to lock it in place so that it can't rotate anymore. So and then I'll open up the constraint window again. And this time we're going to use the mate one. So the first one here, the one that's named mate. We're going to zoom in a little bit, just to get to see a bit more clearly what we're doing. We can see here, if we're holding it on the edge of the hole here, it sort of wants to choose the center point. We don't want that. We want to hold it a bit more into the hole, onto the side of the inner side of the hole, basically, so that it shows us the axis going through the hole. So we can click there. And then we're going to flip our view a bit so that we can see it from the underside here. Need to zoom in a little bit again. And we're going to do the same with the hole on the housing here. So move the mouse pointer so that you have it on the internal wall of the hole, and that you see the axis going through there, and then you click on it. So that's going to move the two axes on top of each other so that they get placed in the same location. So if you have problem connecting the two holes here, it is most likely because one of them has the incorrect radius from the center, so that it can't actually match up the axes, because it can match them up in the amount of degrees of rotation, but it won't get as far from the center out there, so it can't really match them up. So then you have to go back into your part and figure out which one of them has the incorrect one. And the distance from the center and to the center of the flange and to the center of the hole is supposed to be 52.1. But we experienced this problem with a couple yesterday also, where we had on one of the parts, it had 51.2 instead of 52.1 as a distance. So it was just a typing error in the original modeling. But that was enough to make it not want to match up. So I think we'll just continue on now. So I'm going to press the OK again. If you want to, you can just press apply, because you can wait with doing anything until I start constraining again. But I'm pressing OK just to show you a little bit that since we've constrained this hole to the hole in the housing, we now are unable to move the top at all. We can't rotate it anymore. So now it's locked into place. And now we can start constraining in the bolt and the nut. So we'll go back to the constrain. We'll use the insert option again. And then we'll zoom in a little bit on the bolt in order to make sure that we hit the correct edge. Because as you can see, below the head of the bolt, we have this disc going. And it's this disc that is going to lie flat against the material of our flange. So we need to choose either the inner edge of the disc or the outer edge of the disc. So either this inner edge or that outer edge. So one of those two. It's not important which one you choose, so long as you choose one of those two. So in my case now, I'll choose the outer one, since that's the one I have marked. Then I'll zoom out a bit, and I'll zoom into the hole on my valve top, and I'm going to select the edge of the hole. So I'm going to place it here, because then the disc underneath the head of the bolt is going to be placed flat against the top of the hole. And the bolt is also going to be centered along the axis of the hole. So once I click there, it's in the perfect position already. Considering that this is a bolt, it's supposed to be able to rotate in order to fit the nut and everything. We don't need to lock it in place with regards to rotation. So this is the only constraint we need to put on the bolt. So we can then click apply. That's going to leave our constraint window open so that we can start constraining the nut also. So we'll zoom out a bit so that we can see the nut, and I'll zoom into the nut in order to make sure that we hit the correct edge on the nut also. So we'll zoom in a bit here. And here we can see we have a flat disc on one side of the nut. So we need to either do the outer diameter or the inner diameter of that disc. So either this edge or that edge. So I'll choose this one, and I'll zoom out. Once that one has been selected, we now need to see the underside of the flange. So we need to see where the bolt is coming through our housing. So we need to flip our view a bit and zoom in here. And now we're going to select the edge of the hole here also. That's going to place our nut all the way in so that it looks like we've tightened it. So we go to the edge of the hole there, and we click on that one. So I'll zoom in a bit so that we can see it. Now zoom out a bit. Okay, we'll do a 15-minute break before we start setting the pattern on the bolt and nuts. Right, then we're back from the break. So I just need to press apply here to get the nut in place, and then I'm going to flip my view a bit. So what we're going to do now, we're going to use a circular pattern in order to create 3 more bolts and 3 more nuts in one go. So what we do is we go up to the pattern part up here. And there's a slight difference here from doing 3D modeling, because we can't choose between a circular and a rectangular pattern right away. We just have one button for patterns. So we click on this one. And now in this window is where we select if we're going to have a rectangular or a circular one. So we want a circular pattern. So we click on the tab for the circular one, and we can see that the component button has been highlighted in blue. So now we need to select the bolt and the nut. So I'll just zoom in a little bit here so that we can see them clearly. So I'm selecting the bolt, and I'm also selecting the nut. So we just need to click those two in order to get them blue. Then we need to highlight the axis direction button up here so that we get that one blue, because now we need to choose which axis we're going to create this circular pattern about. And then we'll just click on the outer cylindrical edge of the flange here. That's going to give us the center of the flange, which is going to become our axis. And then we can already see a preview of the 3 new bolts and nuts that have been put into place. If we had holes for 6 instead, we could have changed the quantity over here to 6. And the preview should also have changed itself, but it didn't for some reason. But we're supposed to have 4 right now. So that's the one we're supposed to have. So we'll click OK. So then we get all of them in here. And we'll zoom out a bit. So what we're going to do now is that we're going to attach the wheel to the tip of the shaft, so the thin section with threads. So I'm going to flip my view a bit so I can see the underside of the wheel. I'm going to use Constrain, and again I'm going to use the Insert option. And I'm going to select the edge of the threaded hole on the underside of the wheel. So I click on that one. I'll flip my view a little bit so that I can see the tip of my shaft clearly. And now I'm going to select the edge of the inner edge of the thinner threaded part. So once I click there, it places the wheel on top of those threads, so that it looks like we've screwed it into place. And then we can click OK. So what we're now going to do is that we need to place an M14 nut with fine threads on top of here. So we're going to have to go to Place from Content Center on this one. And we're going to use a different standard. So we're going to use the 8673 one. So we need to scroll down a bit. So DIN EN ISO 8673 is the one we're going to use in this case. This has a little bit to do with being able to choose the fine threads and stuff like that. Just let everyone get a chance to select it before I click OK. Right, once everyone has selected that one, we'll click OK. And what we're going to do now is that we're going to move our mouse pointer onto the threads on our shaft. So we're going to move it over here. And we can see we no longer have a red question mark here now. We have a green check mark, and it actually says M14 times 1.5. So Inventor has now read the thread information that we placed on the shaft, and it has chosen a nut that fits those threads. So we'll click there once it's been chosen, and then we need to click where we want to connect it, and we want to connect it on that end there. So I'll just move it a bit to show you here. We want to connect it to this part, so that we get the edge of the wheel there. That's going to place the nut exactly where we want it to be right off. So once that is done, we can click the finish button over here. So this one, which says finish the current insertion and stop inserting. So once we click on that one, it places the nut to our wheel there. So this sort of saves us a little bit of trouble, because we don't need to choose the thread designation of the nut, and we don't need to constrain it afterwards, because we're doing everything at once. It's 8673. So now we only have one thing left to do with regards to assembly. We need to get the shaft inside our valve. And the nice thing here is that we don't actually need to have an opening, because Inventor is just going to move it straight through the material. It's not going to be a problem. You can't have collisions in here unless you actually tell Inventor to look out for collisions. Then you won't have anything. So what we're going to do now, we're going to do another insert constrain. We're going to select the edge underneath the wheel there. And we're going to select the top here, so that we get the wheel all the way down. And now I placed it in the wrong direction. And we can simply fix that, just like if it placed the two flat surfaces in the wrong direction when we used the regular mate. We can use it by switching the solution here. So when I click on the other solution option, it puts it the correct way around. Once we've done this, we can save the drawing. Not the drawing, but the assembly. And the next step will be to create a new file. So we go up to the new option up top there. Click on that one. And now we're going to create a file that we haven't created before. So we're going to scroll all the way to the bottom, where we can see in the blue text here, it says presentation. And we're going to choose the standard in millimeters .ipn file. That's a presentation file, and it means that we can create an animation of our assembly, which is part of what you're going to do in submission 3. So it's important that I get to show you this. So we use standard in millimeters .ipn. Click create. And I need to choose my assembly file, so the one I just created. And I need to click open. Now in the compendium, I was using Inventor 2016. And from 2016 to 2017, they've basically revamped the entire animation stuff, so it's pretty different from what's in the compendium, which means that the compendium won't be all that much help to you when you're doing your animations. So hopefully I'm going to get to show you what you need now. One thing I can say is that it's more intuitive now than what it was earlier, so that it's a bit better to do this, a bit easier to understand. Just to show the layout of what we have here, we've placed our assembly file in here, so we've got all of the parts constrained together. We've also got a timeline down here, which they're calling it a storyboard, which is what's being used in animation work. And what we can do here is that we can select certain points in time where we want something to happen in here. So to begin with, there won't be any reason in doing anything else than starting at 0. We don't want our animation to just stay still for the first couple of seconds. So we want it to start at 0. We want movement right away as we're starting off. So the first thing we're going to do is that we're going to make the nut on top of the wheel. We're going to make it unscrew itself and then move away from the wheel. And the way we do this is to use tweak components. So the one up here. We'll click on this one. And then we just get some information over here. It sets a fixed duration for this one, and 2.5 seconds is the usual stuff it uses. And that's quite fine with us. We can use that. So we're going to select the nut. And now we can see we suddenly got 2 more options up top here. These were grayed out before. So we can either move it or we can rotate it. So the first thing we're going to do is that we're going to tell it to move upwards. And the way we make it move upwards is that we go over to this arrow that is pointing in the Y direction according to our coordinate system. And we're going to click and drag on that arrow. And we're going to pull upwards. We can also, if we want to, we can set a specific length or something, or we can just pull it using our eyes to measure. So I'll just pull it up slightly above the shaft. Right, so what we've actually done now is we've pulled the nut 33 millimeters straight up. And what we've told the inventor is basically that it's going to use 2.5 seconds in order to animate these 33 millimeters of movement. So if we click on the green check mark over here now, we'll see that down here on our storyboard, we've gotten a green line going from 0 to 2.5. So this is going to show us the animation. So if we click on the play button now over here, then we can actually watch these 2.5 seconds. So I'll click on the play button, and we can see the nut moving upwards. So I'll just do it once more so we can see it. But it looks a bit funky having a nut just moving straight up. It's on threads, so it's supposed to rotate while it's moving upwards. So we're going to have to add a rotation to it while it's moving upwards here. And that means the rotation has to happen at the same time as these 33 millimeters of movement. So we need to drag our our timer back to start, back to 0. So we'll pull it back to 0 seconds. Let's see. Yeah, they're at the start. And then we'll use tweak components once more. And again, the duration is 2.5 seconds as a default. It is a pretty good duration when we're doing small tweaks like this. We don't really need more time than 2.5. So we'll click on the nut again. But this time we'll select rotate up there instead of move. And once we click on rotate, we don't have the arrows anymore. We have these sort of degrees shown. So what we're going to do now is that we're going to put in, we're going to drag on this side here. That's going to rotate it around the vertical axis. So we can drag it to 180 degrees, half a circle. And then we'll click OK. So if we run our animation again now, so if we click on the play button down here, we're going to see that the nut will both be rotating and moving upwards. So I'll just run it once more to show. Both rotating and moving upwards. Once we've gotten it off of the shaft, so now it looks like we're actually unscrewing the nut from the shaft, we can move it over to the side so that we basically get it away from the rest of our valve. So we can use tweak again, but this time we let our timer stay at 2.5 seconds because now we want the movement to start at 2.5 and continue on. So we use tweak once more, click on the nut, and then we can use, for an example, the arrow pointing along the x-axis. We can click and drag on that one, and we don't have to move it in the same direction as the arrow. So we don't have to move it this way. We can move it in the negative direction if we want to. So we can move it over there. And still, we can let the duration be 2.5 seconds because it just means that it will be moving a bit faster when it's moving away. So if we then click OK, and we can do a test run on our animation just to see what's happening. So it unscrews itself, and then it moves off to the side. It is also possible to make several components move at once. So I'm going to show that with the 4 nuts that are underneath here. So I'm going to make all 4 of them move downwards at the same time. So I'm going to use tweak components. I'm still going to start off at 5 seconds, so I want this to happen after the top nut has been moved away. And I'm going to select first one nut, then another one, holding the control button. Then I need to flip my view a bit, so I need to move this one. Let's see. So I make sure that all 4 of the nuts are marked blue. So you might have to, you definitely have to hold your control button or your shift button in order to manage to mark several components. Just going to move it back here. And I want them all moving slightly downwards. So just so that they get off of the bolts. So I'll click on the vertical arrow, and again I'll move it in the negative direction compared to the way the arrow is pointing. So I'll just move it down here, approximately 20 millimeters. If I move it further, you'll see that the 2 nuts that are on the side, they will start crashing into the valve housing. We don't want that one. We want it to look like this is a natural movement, so we just move it down a little bit. If we now click OK and try to run the animation once more, we'll see that it's unscrewing the top nut, moving it away, and then it's moving all of the other 4 nuts straight downwards. Now, if we want this to look really good, to look like we're actually unscrewing all of the nuts, we'll have to reset our time to 5 seconds, and we're going to have to add rotation to each of the 4 nuts. Because the problem is with choosing several nuts to try to add rotation to it, it's suddenly going to start spinning everything around one and the same axis. So it's going to basically start spinning the nuts in a big circle instead of rotating them around their own axis. So for rotation, you're going to have to do each one by itself. We're just going to skip that right now so that we can show a bit more stuff here. So I'm going to do another tweak, and I'm going to lift all of the bolts out of the flange. So I'm going to choose 1 bolt and then the other 3. And then I'm going to lift them straight up. Like this. And then I'll click OK. So I'm now going to add 2 other tweaks, Both of them are going to start at 10 seconds. And the first one will be moving these two bolts and these two nuts this way along the Z-axis. And then I'm going to return to 10 seconds, and I'm going to do the other two bolts and nuts and move them in the other direction. So I'll do tweak components. I'll select one bolt, then the other bolt, then the first nut, and then the second nut. And I'm going to pull it along the Z-axis, away from the valve. So then I click OK. Then before I do the other tweak, I return my timeline back to 10 seconds. So I pull it back to 10 seconds there, and you can see the bolts were also moved back into the original position. Then I'm going to flip my view, and I'm going to do the second tweak. One bolt, then the other, then one nut, and then the other, and then I'm going to drag it along the Z-axis, and I'm going to click OK. So if I now move back to the original view I had, I can run my animation once just to show what's happening. So first the top nut is unscrewing, then moving away. Then the lower nuts move away, and then the bolts, and then we move everything off to the side. So the last thing we'll do before this lecture ends is that we're going to use we're going to select the valve top, the shaft and the wheel, and we're going to pull everything out of the housing of the valve. So we're going to do a tweak. I'm going to select the shaft, the wheel, and the top. And then I'm going to pull everything straight upwards until the shaft has left the housing completely. And click OK. So if I run the animation once, we'll see first the nut unscrewing itself, moving away. Then the 4 other nuts and 4 bolts moving away. And then we have everything being lifted up. So this was the very last lecture that we have. The rest, the 2 next weeks, you only have study time here. So the room is available in the usual 4 hours on the next 2 Fridays, so that you can sit here and claim computers. If another class is in here, you can just shoo them away because you're supposed to be here. But also, if you want to work apart from that, just come in there. So long as there is not another lecture going on, you can come in and work on the computers.